Okay, so let's take a look at 11 and 12 from the Unit 12 review. So let's see, the first problem here, 11, two racket balls are packaged perfectly in a cylindrical container. The radius of each racket ball is 1.125 inches. Find the volume of the whole cylinder. Okay, so let's see, volume of a cylinder is given by area of the base times the height of the cylinder. Okay, so let's see what we can figure out. Well, if the racquetball has a radius of 1.125 centimeters, well, that's also got to be the radius of the cylinder itself. Okay, so the area of the base is going to be pi 1.125 squared. And then we need the height. So here's the trick for the height. That's a radius, that's a radius, that's a radius, and that's a radius. So the whole height is 4 radii, right? Radius, 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 radius. So 4r is the height, which is really 4 times 1.125. So let's see what we get out of this thing. This ends up being 4.5. And then if you multiply by 1.125 squared in pi, the whole thing comes out to be 17.892. Let's see, these would be square inches. All right. Let's take a look at the next one. So let's see, we got this pentagonal prism. It's a regular pentagon. Each side is 12 inches. We don't really need all the 12s, but you get the idea. Okay. Find the area of the base. Well, we only need the bottom diagram for that. I can cut it up in congruent triangles here. And one of these angles in the center is going to be 360 divided by 5, which is 72 degrees. So we got 72 degrees going around these guys here. And then the main triangle that I'm going to work with will be this bottom one. I'm going to chop it right down the middle. So it's 6 and 6. So this makes the 72 get cut in half to 36 and 36. So I'm going to need this part right here, the height of the triangle, which I'll call x. So I can't use Pythag, but I can use trig. And if I use tangent, that is going to be equal to 6 over x. So let's see, if I multiply the x over, and then divide both sides by tan 36, then we get 8.25, 829. Okay, so that's the height of the triangle, which means the area of the triangle is 1/2 the base of the triangle, which is 12, times the height of the triangle, which is this thing, sorry, the pen is starting to jam here. So let's see, that comes out to be 49.54975, and then we've got 5 triangles to make up the pentagon. So if I multiply this guy by 5, we end up with 247.74875. So if we round to 3 places, 749. And then we're working in inches, so the area is going to be inches squared. So let's see, what's the next thing that we have? The volume of the prism is 5,000 cubic inches. Find the height. So volume equals 5,000. We know the volume of a prism is the area of the base times the height of the prism. The area of the base we already have right here. That's 247.74875. And the height is just h, but we know that equals 5,000. So if I divide both sides by the 247, I get h. And h ends up being 20.181737. 20.181737 inches. So the last thing we need is the lateral area of the prism. Well, lateral area of a prism is defined as the shortcut formula would now what you could do is you could do 12 times h and then just multiply that by 5. But it's also the shortcut for a prism is perimeter of the base times the height of the prism. Well, the perimeter of the base is 12 times 5, so that's 60. And then the height we have right here, 20.181737. If you multiply that by 60, you end up with 1210.904. 1210.904 inches squared because it's an area. Okay.